long-term carbon dynamics in forest, especially in the large area, such as nationwide or continent-wide, and because of this, the limitations of the personal equipment and phones and the environmental conditions. So but it's the models that can do this because it is the model developed is based on the expert knowledge and long-term experience and observations. So we can use model to do this work. And what is the Forest-DNDC? This Forest-DNDC is a member of the DNDC family. This is the geocap model to simulate forest growth. Thermal is the hydrothermal balance is the system based on the drivers. And then we simulate the photosynthesis. The photosynthesis is based on the several. One is based on the hydrothermal balances, and it's also we have to check the system the nutrition is enough. Nitrogen and is the soil. Gross primary GPP. part of the plants. Wood or the is the ground, and is the we can simulate is the organic matter decomposition, and based on is the different decomposers, and is first we partition is the organic matter into three components, and it's the very label and label resistant, and based on this the species, and it's because it is vegetation is the plant species, so we already is one of the inputs. So based on this, then is the we can simulate it, and it's the organic matter in different pools, and also is the during the decomposition, and is the how many nitrogen and phosphorus released from that is the decomposition, and it also is the how many carbon dioxide released to the air, and it also dissolved this organic matter is to keep it in the soil, and is to get into the water or whatever else. Conditions it is that is mineralization, and it also is the way and it is special is the nitrogen is the very that is there's through this the nitrification and denitrification, and then is the we can have all those this trace gas. And also this the method, it is depend on the method conditions, this the wetland or upland, and so this that means it is based on the soil moisture. What is that? And then though simulating all those, and it's the summarized, and it's the gifts that give all those this the what is this? Just the here close, and then is the we can give this the outputs. Those is the main outputs, and as we can have more, but it's the here is I just show you this is some of this more. You can find. Oh my gosh, it is the one. Oh, what is the habit? Let me check this. Okay, now this you can. Oh my God, sorry, this before that. Okay, that is the. Nowadays you can find the screen. Okay, this is the. Okay, now this is the key impulse. That's what is the you need is for the model to parameterize the model. Is that first we need the location, altitude, and is the elevation. These two parameters are very is we need, and also this the we need atmospheric the carbon dioxide. Excuse me. And is nitrogen deposition. and those is the is mainly the especially is the dry and wet depositions. And soil is the we did is almost very detailed is the soil properties, and is the includes the carbon content, it's the, and it also need is the texture, and those is the we had, and also is the we need the hydraulic conductivity, and is to simulate the ET, because it is that. And vegetation that's this the species this or species group, and we need a standard. Species what is the we just need is the species the group. We don't need a very detailed like the pine, and is we just need is the pine, and is you notice the pine again is the very detailed is the different species. We just need notice what's the pine, a standard, and that's just what we need. And it's more problems that we have to very detailed is the phenology data. Now, phenological data that we need is for each vegetation layer, because it is this model and it divided into this the vegetation into 3 layers. One is first layer, and it's the overshape and story and ground growth. So all those is you have to have this phenology data. And those is that we can, if anybody uses this, there's the, we will give them the user manual. This the what is the exactly need, and also this we have this the database and collect this data that you can copy paste and use that or modify that. Climate data is it is the but it's, we have to have this the daily data. Daily maximum and minimum temperature and daily precipitation. Because this model, the times state is daily, so that's we need daily inputs. And disturbances is that's exactly only this the driven by events. What is the occurred, and is you just give exactly what is the good, including that is the harvesting, thinning, planting, water table control. This is only for the wetland, and it's hurricane or is the cyclone, strong winds, and is anywhere is you just give exactly the events, and including the time, and is the damage level, and then is the model can range the golf to run that. Okay, we did some simulations. This is for Mexican is forest size, and we did is the first, and is the we did the simulations for this the just plot level and to test the model. It works or not. And also this we use the model to simulate for the larger size. First we did is for area, this the quick here is the there were this 23 this the plots. Each plot has this 12 subplots. So this total there are 276 subplots. All those plots we run separately. And this is the formula. This is the result we publish. And also this we did is the one time for this at Pixco. And this is we didn't publish. We just test the model that can use for this the other places or not. And it's because this is mountain area, that is the quick, is the planet area where it's on Yucatan Peninsula. That's also different area. And then when it's the use this model to simulate for the another larger area. This is the whole Lhasa scene is this because this, we have the disturbances data from Lhasa. So this, we use this whole Lhasa scene. This is the total size is about 33,000 square kilometers, but it's the only this plus cover area is smaller. So this we did for this the 3 simulations. Okay, so this now this we can find is the what is the result, and for this the plot. This is the plot label. This is the plot label is for week, and it's a weekend is the that's okay. That's the 1 to 1 line, and that's the weekend is the slope is the just very close to 1, and it's also does this. Except is also this the small. So that means this for plot level or subplot, this model it works, and this is just for this pixel, and it's based on those this that we can find is the both sides, and is have this the good result, and is from this the model. And that is we also is the compared that is the result, and is with the other results you can find is this is the data from Gregorio, and is the Gregorio, and is this is the Mexican is the inventory date, and is the 2 types and is we use this the Yucatan, that is the site is the applied data, and is the compared this, and so there's some assets is just a little higher than is the inventory date, and it's only for dry forest it seems a little lower is the during the when is the stand age is older, maybe this is a little different. This inventory data is seems higher, and there's the one is the younger is that's okay. So this, and here is the for this the moisture is the forest is seems similarity is the little higher than is observed. This the very there is then is the you notice biomass just one is the soil carbon is also very important. So this the soil carbon is this is the soil carbon dioxide is just released from the soil. So this we can this is for Creek area is 23 plus, and it's each sub plus each bar is that's each side sub plus. So this all sub plus is here, and is you can find is that's different. So process is different. It's not constant. It's the same. That means they're different. And here is the for this plot level is the average. It's for long term, and it's almost 40 years. So this the 40 years trend, and is what is the soil carbon flux. But then is we use this model to simulate this for this region area for region. So we just mentioned is for this the one Lhasa scene, and it's but if for this is we need is the inputs. We need is the GIS tool to help this the prepare this the inputs, because this is the too large is the we very difficult to use this observed this environmental parameters, but we can use GIS data to parameterize this data, and it's including the soil. You can use the soil data, this the GIS, and also this we need is the elevation data. So this is the GIS. This is we can have that data this to join this all together. Here is that's the story. So this is Lhasa saying, and that's this the here this is the disturbances data. So this we have to join all those the basic information together because the one polygon data as the input. So this we join is the including the vegetation information and is the soil and climate. Climate data is point data and is joined together. Is the and it have to make sure that each is the polygon has that is the climate data, and that is disturbances data, and it's also just joined together, and it's all those. And it's the we raise the model. This is 30-meter resolution, and it's for cubic. So this we can find is the you know this where this the biomass is high or is low. The biomass is this area is high, and the center is seems to be here. And this is for this the loss of sand is for cubic. This is the you can find is the all those the exact where is the location is the on our report. This you can check this the report what is the where is there, and this is the MPP. What is the where is the higher is the carbon sequestration, where is the lower? That is similar. This is the area is lower, and this is area is the higher. And here is the biomass. The biomass is a little different. Only here is the higher. And it's the MPP is the same as here is the high, but it's maybe here is the tree is young and slow water. And this is soil carbon dioxide. And then as we summarize this, for whole is loss of sand is the for area is the total is the this is total, and is the total, and as we can find is the biomass accumulation is increased from 1984 to 2010, but that is the MPP. It is the same as the only here is the 1980s, it is the highest, and it's become lower. And it's lower, that's related to many things. One, MPP is also depend many things. This depends on the climate, depends on the disturbances of the water, and this is the NEP. Of course, it is the MPP is low. Is the NEP is low. That's this is the dash line, and that's the red dash line. That is the MPP. So as you can find MPP is the here. I can see this the which year, and this MPP is less than 0. That means it's a lot of the or cut, and it's so this cutting, and also this you can find is the accumulation is lower here, and it's coming down and then continue increase. So this is for the whole loss of sand, the summarize. Okay, so we use this also use this model to predict the climate change. The influences, and how the effects of the climate and disturbance on the carbon sequestration on the peninsula. So we are just assumed. We assumed this is not exactly this the data. So we assume this those disturbances, fire, no matter, but it's the only this is the ground fire, not is the canopy fire. That's because this area is I believe that's very difficult to has the canopy fire, and it's so this we just assume this the ground fire, and this is thinning just. Forest management to the thinning, and this is a hurricane, or is any strong is the wind, and but it's here we assume that's the fourth category storms. That means very strong, and also we assume the precipitation decrease and precipitation increase, and temperature increase. Temperature rise is just 2 degrees, just what and this is summarized, including the temperature increase and precipitation increase. Both is the increase because, and this is that is including all those the fire, thin hurricanes, all those disturbances. Maybe it is the last one is this just use this the current condition. That's 2010, the 2010 condition. Okay, so now is that we can compare this. That is the what is the difference? That means this. This is the dashed line. That's the base. That's base. Base. All those is the rainfall is precipitation. Now precipitation that's this is increase, and is the black. That's just the base, and it's based on this. So we can find is the base is the forest biomass is subtracted the so this we can find, and it's different, and is the one is the precipitation lower than is the 1200. What is the increase the biomass? If it is the higher, then it's because that's you can is the black line. Black line that means this original, so there's the precipitation. So this the only this is the zero line. That means without any influences. So this means only the precipitation below 1200. That means no influence. And you can hear it much lower. And here is the precipitation is higher. This the increase does not work very much. And then is the biomass is the increased, and is the long-term trend. But that's we just increase the precipitation 10% based on the original precipitation. So this for this whole period. So, and that is the we put is the almost the other is this is we can is this is precipitation. This green line that is the precipitation increase, and is the this purple that is the precipitation decrease. You can find it's the low different for Yucatan Peninsula. That's the decrease. The precipitation is decreased by 10%, a little lower. The biomass is becoming a little lower, and thus the increase by 10% is just a little increase. So that's this about it is if without this is just middle. So, and what is means this precipitation? That is the here is the Yucatan Peninsula is not very sensitive is to the precipitation, just change 10%. What is it? Very sensitive to change the temperature. The temperature rise by 2 degrees, and you can find that is the biomass decrease very fast. Also, that's related to 2 things. One, and is the biomass is the growth rate becoming lower, and is the more is the tree maybe sometimes some periods, especially dry period, this maybe diet, and so this the biomass accumulation becoming low. And here is the carbon pool. The next, the bottom that's to show this the carbon pool. So this you can soil carbon means one is the increase is the precipitation, a slight increase. What is the one is the decrease is the precipitation, and at first almost no difference. That is slight to become more. and because this become more maybe related to this and precipitation lower and is some liter become higher, and but it's the long time that's different currently, then is become decreased, and then is or the temperature that will influence very large, very strong, and it causes the soil carbon loss. Okay, so now this we put them all over together. So that's all the disturbance. The thinning, that's this black line thinning. We assume this the thinning and is at this point and start to thinning. So this the cut and how many percent of the tree cut, and so this the biomass becoming lower. And then it's the after cut, and from this point and is the increase and is recovered. The last maybe 40 years at least, or 20 years. How many years am I old? I have to based on this, and it's almost 10 years and it can recover. Or so 20 years maybe to here this thing can recover that. And then it's the fire, and it's the fire is you can just slide the fire. This point is here. The fire is the emphasis is very small. As you know, that is the Yuc temperature. So that is the forest floor is very low. So the fire is because the ground fire is the main thing. Is just influence the forest flow. So that's influence is very small, and it's the hurricane. That's a hurricane. 100% because of this, we assume it's almost over 80% that by the fourth grade, the greatest the hurricane destroyed. That is almost tree is 80% of the tree gone. So the biomass decreases very fast, very more, and that's a red line. That's putting all three together. So so that's why here is the low, because including this, and so this. But as you can find is here and is put it all together. But it's only here is just a little different because it is it can. That means this after disturbance, the forest can recover. And here this all those disturbances. Influence this soil carbon. That just we can find this. Why it is so? This means this a lot of because this the hurricane is can left the many debris is just on the forest floor, and then is decomposed, and what is very short is the loose is the organic matter on the floor. Okay, thank you. It's everything's there, right? Any question?
¿Alguna pregunta para Dai?
Hello?
Hi, yes.
Okay, thank you.
¿Sí pueden abrir el micrófono?
Yeah. No? Okay.
Can you hear me, Dai? Yeah, we got some questions.
Yes, please.
Can you hear me?
Yeah.
Yes,
Hi.
please.
Hi, Zhaohua. This is Rich Birdsey. How are you?
That's good.
Yes. Hey, could you speak a little bit about your current work with developing a version of DNDC for mangroves?
Could you please louder? I can hear this very clear.
Could you say a little bit about your work developing a mangrove model?
Mangrove?
Yes.
Oh, you want to so the mangrove is the you want I have this the mangrove is that I can give the just introduce this the here is the what is the I have PowerPoint what is the but it's that's is the mangrove is the model is the we already developed and is the we already is the simulated the for this the that is we just published this the two papers this the journal is already accepted. So that's this the we can find is the we send you a copy is the when is the it's ready. And that's this the we developed this the model and based on is the almost that is the concept is the very close to this the Forest-DNDC. It's only is the simulates the carbon dynamics, there's the carbon, nitrogen, phosphorus in the setting water system. It's because that's so much different from this the fresh water. So this the we changes the which this the new model. So this the you just let me check this stuff out. I don't know where this the if this the you can wait this the I can is show you this the we also this the use this the Mexican guy Mexican okay. There is the mangrove is the we there is the finance what is this?
That is fine, Zhaohua. If you don't find right now, if you can share it with us by email, we can share here with the attendant. Estaba cerrado.
Okay, now
That's-
you
that's-
can see it is the mangrove is the
Is that the publication, Zhaohua?
yes.
Is that the publication about
to
the?
show you the result. And that's just the mangrove forest. We can have some results already. And it includes the your is the Mexican side. And is the we you can find is the screen right now. It is the here. And it's the, also this is the mirrored compared to the mirrored and the simulated. And okay, so that's I don't want to show this too much here.
That's fine. So, do you have any document with this project on the mangrove forest?
Excuse me?
Do you have any document to share with us with your work in the mangrove forest?
Oh yeah, so the weekend is the I can send you this the all this the mangrove for this document. So the include is the manuscript so that is ready to publish. It's already the conditionals is the accepted, but it's the one is already is that is the proofread. Another one is the waiting for this proofreading, I believe.
Oh, okay, okay.
So it's the after if you want to this the publish this the maybe this the we have to wait for several weeks. But I don't know. This journal is the it's very very slow. This the I sent is the manuscript there is already over 1 year.
Okay, thank you. Thank you. Somebody
Yes,
else
I
have a
will
question?
Yeah.
If not, we were gonna thank Zhaohua for his presentation and for sharing with us his experience with the DNDC Forest for Kiwik site. Thank you, Zhaohua. And it was very good to
Okay,
see
thank
you.
Thank you.
Thank you.
Thank you.